Hello there. Today I'll be presenting our paper for NAACL on long-form evaluation of model editing. This work is supported by the Kiln Foundation and the Vector Institute and is done as part of my PhD work at Dalhousie University in Halifax, Nova Scotia, Canada. First, we motivate the problem by discussing model editing for large language models. With model editing, we're asking the question, can we directly intervene on model weights to change factual or conceptual knowledge? Can we do this in a sample-efficient manner, such as if we only have one example? And can we do it in a targeted, compute-efficient manner with minimal changes to the underlying large language model? For example, an edit might be, the President of the United States is, typically the large language model would say Donald Trump, but you want to edit the large language model to update its knowledge to generate Joe Biden. A rapid overview of the techniques used typically in model editing are constrained fine-tuning, where we fine-tune a few parameters using full fine-tuning with some constraints. MEND, where we train a hypernetwork to learn to edit a model using gradient information. ROAM or MEMIT, where we discover the parameters contributing to the pre-edit knowledge and replace them with new parameters. And in-context knowledge editing, where we use in-context prompts to demonstrate how to edit. When we look at the evaluation of model editing, we typically look at a few properties. The first is efficacy, where we're asking the question, was the edit actually made? Here we prompt the large language model with the prompt, the Eiffel Tower is in, and after making the edit, the Eiffel Tower is in Rome, we expect the completion Rome. We also want to know whether this knowledge generalizes. So here we have a paraphrase of the prompt, where is the Eiffel Tower? And we expect the completion to be Rome. Similarly, we have evaluations of whether there was negative side effects, such as where is the Champ de Mars, which is located in Paris. We would expect it still to be located in Paris, but if the completion is Rome, then we have poor locality. Finally, we want to understand if the model edit has positive side effects. This is called the portability of the edit. So for example, if we have the prompt, what are the restaurants around Eiffel Tower? Since it's moved to Rome, they should be restaurants from Rome. But there's a problem with short evaluation. While short evaluation looks good by looking at the next token after a prompt, or the next few tokens, we don't really understand the impact of model editing on a long-form generation, such as a paragraph or a set of paragraphs. Will the knowledge be reflected in that long-form paragraph or not? And this is the motivation for our paper. How would we evaluate long-form generation quality after a model edit? We construct our instrument for evaluation using a few different properties that are supposed to reflect efficacy, generalization, locality, and portability, but in the long-form setting. These are edit consistency. Is there evidence the edit was actually made? Factual consistency. To what extent are unrelated factual statements still true? Internal consistency. Do passages contradict themselves? Cross-passage consistency. Do independently generated passages contradict each other? And a few measures of natural language generation quality, such as do passages stay on topic and the fluency of the passage. In order to do this, we construct a new data set called coupled entity prompts. What we do is we have an edit, and we perform it, and then we ask the model to generate a subject prompt by writing an article about the entity in question that's been edited, including properties about that entity that might be impacted by the edit. Similarly, to understand the impacts on natural language generation across different generations, we have a related entity prompt, in this case Champ de Mars, and we similarly ask to write an article about Champ de Mars and include a number of properties that would be impacted by the edit. we do this for we construct this data set for standard model editing evaluation data sets, counterfact, and ZSRE. And here are some examples of our couple entity prompts data set, where we have generations for the subject prompt, generations from the related entity prompt, and we might have parts of the passage that reflect edit consistency or that contradict edit consistency. In order to evaluate this fully, we used our instruments to construct two evaluation settings. First is a survey setting where we had 3 different interventions: the edit, the no edit, and human written passages. Then we did a survey where we asked a number of participants to evaluate the degree to which the edit was reflected in the passages generated by these 3 interventions. Next, we had an annotation setting where we had a number of annotators annotate whether or not the sentences in the generated passages reflected the edit or contradicted the edit. And again, these are the properties in question that we used for our survey. Just to look at our survey, what it looked like, we had a 7-point Likert scale where we asked a number of questions that reflected these constructions back here. And we had our generated passages from our main passage and a related passage from our 3 interventions. Generated passages by humans, generated passage is from the model that wasn't edited, and generated passages from the model after being edited. For our annotation setting, this is what it looks like, our annotation interface, where we have some claim and we have the passage, and we want to understand whether that passage contradicts the claim, is neutral with respect to the claim, or supports the claim. Our second research question was, using this data that we collected from the annotations and the surveys, can we construct automatic evaluation methods to assess the impact of model editing on long-form generation quality? We were able to train a set of models that performed very well and correlated well with human annotators and survey takers for the survey rating task and the classification task. We use this automatic method to evaluate a large set of different standard methods for model editing across different models. What we found was that while methods like LEME and MEMIT, who perform well on our standard short form evaluations, they don't perform as well for other measures like factual consistency, such as whether other unrelated ground truth properties are true, and internal consistency. For example, whether the knowledge in the passage contradicts itself. How do different editing method generation quality compare? Well, we did find that the ground truth is true in our automatic evaluation setting more often for in-context editing, MEND, and the no-edit control more than MEMIT and LEME. Similarly, the edit statement is true more often in MEMIT and LEME passages. What is the relationship between short and long form evaluation methods? We found that there is a very slight positive correlation for some properties, like edit consistency and cross-passage consistency, but most of these properties had very little correlations with the long form evaluation methods and were often not statistically significant, which points to the value of our methods for evaluating model editing techniques. Finally, we asked, what specific problems does model editing have when it comes to generation, to long-form generation? We identified a few of these, such as disfluency. For example, Tony Benn was a British politician and Bostonian, where Tony Benn was edited to be a Boston politician. And we start to see these generations, such as he served as the Boston, 2005 Boston, etc. We noticed a common pattern with issues with lexical cohesion. So, for example, de long is the subject of the edit, but this subject degenerates over time and becomes Deloy or Deloy. We also noticed several cases of internal contradiction where the edit was true in the first sentence of the passage, but shortly was contradicted thereafter. This again underscores the importance of doing long-form evaluation when looking at different model editing techniques. In our paper, we have several other issues that we identified with the impact of model editing on long-form generation. Future work, we still are not certain of the entire scope of the change for model editing. How do we know what ground truth should or should not change? These are important issues when developing model editing techniques and should be looked at in future constructions of long-form evaluation methods. If you have any questions, you can reach out to me at my email here. There's a link to the paper in the QR code and here. Thank you for listening.